Okay, so one last time here, I think I can get the last piece of this content um, delivered through this final segment here. So let's see how this goes. A couple more figures, a couple more sets of figures to describe the work of here. So again, just to put these first two in context, we have Johannes Müller, arguing for the value of experimentation. Two other individuals who followed through on this encouragement were Gustav Fritsch and Edward Hitzig, working in Germany. The story for these folks is they do some research with dogs where they expose the cortex of the dog's brain, and by electrically stimulating a piece of it, they can make the dog's limbs move on the opposite side of its body. Again, sounds very cruel, relates back to some of the moral and ethical issues we spoke about with regard to animal research in the last recording. Let me at least describe where the insight to do this work came from. Hitzig was a doctor serving, I think, in the Prussian War, if I'm not mistaken, and was treating a soldier with a severe head wound. And what he noticed about this particular soldier was his skull had been damaged and the brain was exposed, and as he put pressure on there to stop the bleeding, he found that as he pressed the bandage, the soldier's body limbs would move on the opposite side of his body. And this unfortunate accident, sort of a la similar to what Broca did with patient Tan, inspired him to think about how maybe the brain is the master controller of these movements. So you can see again how we're getting more monistic here in placing the brain at a central position with regard to making sense of our various aspects of our being. And so Fritz and Hitzig together did this research on dogs and found that if they electrically stimulated one side of the brain, they could trigger a reaction on the opposite side. Let me show you a funny video here since it'll spice things up. Here we go. So, similar to the idea of electrical surgery, here you go.
Okay, let's see what we got here. This is cool. Hours on ethical. I don't have time to sit around searching travel sites looking for flights and hotels.
Just use Kayak. It compares hyper to travel sites in seconds.
Well, I guess you're the brains of this operation.
Compare hundreds of travel sites at once. Kayak. Search one and done.
So there you go. A bit of crude surgical humor to try to speak to this point of the brain being the center of control for movement around the body, which prior to this time people didn't really appreciate and realize. So Fritz and Hitzig were among the first to get at that. So for these last few individuals, let's go back here, Florenz, Broca, Fritz, Hitzig, they're all following through on the idea of the value of experimentation, of intentionally changing things and seeing what happens. There are two final individuals here, one of whom you probably recognize, who still continued with careful observation and also learned a lot, so let's talk about them. They are Charles Darwin and Alfred Wallace. They are co-credited with coming up with similar ideas of evolution at the same time. The story that I've heard was Darwin proposed his particular version of evolutionary theory at one point in time, but was hesitant to share it because of how controversial he thought it would be. Darwin and Wallace were both members of the same fancy scientific club in London. They knew each other, and several years, if not decades after Darwin had written this idea down, Wallace reached out to him and said, hey, I have this new great idea for how I think evolution might work, and he shared it with Darwin, and Darwin went, oh, that's my idea. And so after consultation, the scientific club they were members of decided to give them co-credit for the idea. Now, Wallace also kind of had a flair for the unconventional. I think he was interested in what was called alchemy, where you take everyday kind of average metals and turn them into gold and other kinds of strange things. And those who were interested in science didn't think too fondly of alchemy. And Wallace eventually, I think, gets himself discredited and kind of shunned to the side because of his behavior. and thus we're left with Charles Darwin being the only person that most people have heard of that's linked with this idea. Now, to put a couple of corrections into context, Darwin and Wallace did not invent evolutionary theory. Evolutionary theory simply talks about how things change over time, and that idea predates them. People were talking about change over time among species before them. What's unique to them, though, was the particular mechanisms that they introduced that they thought might drive the change over time. And so let's talk about one of them. One of them was this idea of natural selection. So some translations of a book's definition. Natural selection, reading it off the overhead, the process by which inherited traits that confer a selected advantage become more prevalent in the population. If you understand that, great. When I first read it, I kind of scratched my head and had to pick it apart to figure out what it meant. Here are some attempts at translation. In that statement, selected advantage refers to anything that increases an animal's chance of surviving and reproducing. That's all that the advantage means. So if anything happens to an animal that gives it a better edge at reproducing, a better edge at living, a better edge at avoiding being, preyed upon or whatever, natural selection says you will end up eventually, later on, with more members of that species that have that trait, assuming it's biology or genes that gave rise to it in the first place. So a final translation of what this sentence then is speaking about, it says, is genetically influenced traits give an animal an advantage. You'll see more animals with those traits in the future. And we would be included in that list of animals. So natural selection was one of the ideas that Darwin and Wallace came up with to speak of how they thought change over time would occur. Now, one common conception, it's actually a misconception of evolutionary theory with regard to human beings, is that, Darwin said humans descended from apes. And it turns out he didn't say that. What he did say, critics of evolutionary theory don't like very much either, but the idea is it's not that apes eventually turned into humans. Instead, it's arguing that apes today and humans today, if you go back far enough, we have common ancestors. And that's the other idea that I'd like you to link with these folks. It's the idea of common descent, which you can see right there. So common descent is making the argument that all life on this planet is related to each other. If you go back far enough in time, you find common ancestors, common relatives that diverged and turned into different species. This doesn't prove it, but here's a nice example that illustrates this. Here are 3 embryos. One of them is a chicken, one of them is a salamander, and one of them is a human being. Looking solely at these, can you tell which one is which? It's amazing how similar we look in the beginnings of life. Now, it turns out it's the right one. Okay, so this is us over here. And obviously, as the genetic code gets read and interpreted, we change and morph in the distinct ways that become each of these different species. But it's quite intriguing how similar life starts on this planet, even with very, very different species relative to one another. So, like animal research and some of the controversy surrounding it, I don't view it as my job as an instructor to tell you how to think about that. That's a personal opinion that you need to come to on your own. In a similar vein, evolutionary theory, at least outside of science, is very controversial today. Some of the claims that evolutionary theory makes about the nature of life on this planet contradicts people's religious, spiritual belief systems and so forth. For this class, you don't have to believe in evolutionary theory from me. Again, that's another personal belief. What I would ask, though, is that as a set of scientific principles, how does it argue that change over time works? That's something that I would ask you to know. So you don't have to agree with it, but I would like you to be able to explain it. Okay? All right. I think that's good enough for this historical review. We touched upon the figures that I wanted to get to, and what I'll do tomorrow is kind of pick back up where we left off, and we'll see where that leaves us. Okay? So thanks for watching, and I will see you in class. Take care.